Okay, good day, ladies and gentlemen. So today I want us to do calculus, and then the first part that we're going to look at is differentiation using first principles, and then this is the formula that we're going to be using. So this is your first derivative here, and then this is the limit as h approaches 0. Then here you have f into x plus h minus fx over h. So this here represents your first derivative. So what your first derivative is just gradient at any point on your function. So this is just a gradient at any point on your function. So let's take, for example, you are given a function like this. Fx is equals to 2x squared. And what is required from you is to differentiate this function using first principles. So of course the first thing that you're going to do in this case is to write your formula. So let's just write that formula. So you're gonna have your first derivative equal to limit as h approaches 0. Then here you have f into x plus h minus fx over h. So just make sure that you write your formula first before you start with your differentiation. So and then also make sure that you include your limit throughout. Don't omit this limit. So you have limit as h approaches 0. Then you have 2. Then what we're going to do here is that into this function where we see x, we're just going to replace it with x plus h. I hope that makes sense. So where there's x, you just replace it with x plus h. So this is going to be 2 into x plus h all to the power of 2. Then minus fx. Fx is still this original function. So minus 2x squared then over h. So this is the first part, right? Then you maintain your limit. So this is limit as h approaches 0. And then now for this you can just use your distributive law or your FOIL method to navigate your way through this part. So this is going to be 2 into, this is going to be x squared plus 2hx plus h squared. This is what you get from distributing this, right? Or opening two brackets for this. So then minus 2x squared over h, right? And then you maintain your limit, so you still have your limit as h approaches 0. Then now at this stage we can distribute the 2, so the 2 will multiply everything inside this bracket. So this is how your 2 is going to be distributed. So you're gonna have 2x squared plus 4hx plus 2h squared minus 2x squared over h. So this is what we have at the moment. Maintain your limit, lim as h approaches 0. And then we can see that these two are like terms. So 2x squared here and negative 2x squared are like terms. So you can definitely cancel this because this is positive, this is negative. So they just cancel there. And then what we are left with is 4hx plus 2h squared over h. And then I hope everyone can realize that h is a common factor here. H appears this side and also this side. So one is allowed to take out h as their common factor. So you maintain your lim as h approaches 0. Then let's take that h as our common factor. Then this is your h. You're gonna have 4x plus 2h over h. And then what's going to happen from here is that h here will cancel h here. Then you're gonna have your limit as h approaches 0. Then this is what, 4x plus 2h. Remember, h cancelled h. So this is what you're left with. But also remember again that the rule says as h approaches 0, so the approximate value of h is 0. So it's not exactly 0, but it's the approximate value. So at this stage where you've simplified your equation to the fullest, then you're allowed to substitute h with 0. So where there's h, you can put 0. So the end result to this will be your first derivative being equals to what? Being equal to 4x. Because remember, if I'm to put 0 here, this part is going to be eliminated. So basically, the first derivative to this function is equals to 4x. So what that means is that the gradient at any point to this function is equal to 4x. So if you are required to get the gradient of a tangent where x is equal to 1, it means you're just going to substitute that particular x value here. So but okay, let's take another one so this makes sense. So let's take this function. Let's say you are now given fx equals to, let's say 3x squared plus 2x. So let's say this is your function, and you're still required to differentiate this function using first principles. So of course, the first thing that we're going to do is to write our formula. That part is extremely important. So let's write our formula. So this is our first derivative, equal to limit as h approaches 0. Then this is fx plus h minus fx over h. Then you maintain your limit. So this is limit as h approaches 0. Then we do substitution into this formula. So remember the rule. We said where we see x, we're just going to put x plus h for the first part. So this is how it goes. So this is going to be 3 into x plus h all to the power of 2 plus 2 into x plus h. So what we did here is just substitution into this equation. Substitution is such that where we see x, we just replace it with x plus h, right? So minus fx, so let's put a bracket there and subtract our function. So this is what? This is 3x squared plus 2x over h, right? And then now let's use our distributive law to deal with this part. So this is going to be limit as h approaches 0. Then this is going to be 3 into x squared plus 2hx plus h squared. And then we can remove this bracket here. So this is what? This is 2x plus 2h minus 3x squared. Minus 3x squared minus 2x. Remember, this is negative, so when you distribute that negative, it's going to be minus 3x squared minus 2x, right? And then over h. So, but this is not fully distributed because there's still a bracket here. So let's work on removing that bracket. So you have limit as h approaches 0. Then let's distribute the 3 there. So this is going to be 3x squared plus what? Plus 6x plus 6hx plus 3h squared. And then plus 2x plus 2h minus 3x squared minus 2x over h, right? And then one can realize that 3x squared is positive here and 3x squared is negative here. So these two can cancel. So 3x squared can cancel that negative 3x squared. And also here your 2x is positive, your 2x is negative there. So you're allowed to cancel this 2. So then you still maintain your limit. So this is limit as h approaches 0. Then let's check, what are we left with? We're left with 6hx plus 3h squared plus 2h over h. So you maintain your limit. So this limit as h approaches 0. Then let's check. at this stage, I think you can realize that h is a common factor here. So let's take it out. So we're going to have h into what? 6x plus 3h plus 2 over h. So h cancels h. Then you have your limit as h approaches 0. Then let's check what are we left with. We're left with 6x plus 3h plus 2. But at this stage, remember, this is simplified to the fullest, primarily because these are no longer like terms, so not so much can be done from here, except for substituting this part by 0. So therefore, it means your first derivative is going to be 6x plus 2. Remember, if you are to replace this h here with 0, or this is just going to be 3 times 0, so this part is just going to be eliminated. So hence we say our first derivative in this case is going to be 6x plus 2. I hope that makes sense. So this is how we differentiate according to first principles. And then the next segment of the session is going to be differentiation using power rule. So let's look at differentiation using power rule. So power rule will allow us to navigate okay.